Hello, I'm Elahe, and today I'm going to have a poster presentation on the k-Robinson-Foulds measures for label trees. This is a joint work with Gabriel Valiente and Luxin Chang, and you could reach the paper by scanning these QR codes. Let's start with the motivation behind this work. The evolution of tumor cells is modeled using label trees, but existing measures for the comparison of these trees have some limitations. For example, infinite site assumption is observed in the most of existing measures, which says in a label tree, distinct nodes have disjoint labels. Also, existing measures allow for the comparison of one label trees like T1 or at most set label trees like T2. So in this work, we introduce KRF measures for multi-set labeled trees like T3, in which nodes are labeled by arbitrary multisets. Then I want to define KRF measures for one labeled trees. For a one labeled tree T and integer k, 0 or greater than 0, each edge induces a pair of sets defined as this. For example, in tree T, for k equal to 1, HE induces a pair of two sets. Each is defined to be the union of the label of nodes which are closer to one endpoint and are in distance k of that endpoint. So because k is equal to 1, in this case, we have f and h in the first set, and then we have a and d in the second set. Then we collect such edge-induced pairs, and we define KRF dissimilarity measure between two one-labeled trees as the cardinality of this symmetric difference. Then we have an example. Intuitively, T1 and T3 are more similar than T1 and T2, but we can see that RF measure of T1 and T2 is less than RF measure of T1 and T3, while we have an opposite result when we compare them via one RF. Then we have some mathematical results for the measures on one label trees. Proposition 1a says that if the label sets of two one-label trees are different and k is less than this value, then we have an upper bound and a lower bound for KRF measure of them. And then part B says that for sufficiently large values of k, KRF measure is indeed RF measure. And then proposition 2 says that KRF measure is a metric on the space of one label trees. Then we have a figure showing the distribution of the frequency of KRF scores for one label 7-node trees. As you can see, the distribution is Poisson for k equal to 0 and 5, while it is not Poisson for the other values of k. Then here I want to extend definition of KRF measures to multi-set label trees. Definition is similar, except that when we want to compute edge-induced pairs, instead of taking union of the label of nodes, we take sum. So for example, for tree T and HE and k equal to 1, we have CF2 here and then ACD here. And proposition 3 says that KRF measure is a pseudometric on the space of multi-set label trees. Then in the next section, I want to define the KRF measures for rooted trees. Definition is very similar to unrooted case, except that here we consider ordered pairs. For example, in this tree, for HE and k equal to 1, we have A, B, C, D, 2, E, F, and A, B, E, G. Then I want to show you how these measures are correlated to three existing measures, namely k-set intersection, this intersection, and generalized Robinson-Foulds distance. For that, we computed Pearson correlation between KRF and the measures. The analysis were conducted on rooted trees with the same label sets, left figure, and with different but overlapping label sets, right figure. And we are, as you can see, the correlation value decreases when K increases at first, and then we have an increasing trend when K increases in the case of same label sets, but in the case of different label sets, we observe a decreasing trend when K increases. Lastly, I want to show you how KRF measures can better cluster trees according to their label sets compared to the other measures. For that, we computed the Silhouette score of clustering 250 rooted trees, which formed 5 tree families, where trees inside each family had same label sets, but trees inside across the families had different but overlapping label sets. And we observed that only for K equal to 12 to 19, KRF measures could recognize the exact number of clusters, and no other measure could recognize the exact number of families. And that's it. Thank you for your attention.